everybody. My name is Abhigna Srinivas, and I'm a senior software engineer at Netflix. My team mainly works with website, that is netflix.com website teams. We build tools and pipelines to help assist in their day-to-day work. So today I'm going to be talking about maintaining and upgrading custom test frameworks. As we all know, change is always a pain. Regressions and unpredictability, whether it comes from feature work or maintenance or upgrading a tech stack, are sometimes unavoidable, especially when we don't have enough safety nets. And unfortunately, if that is a commonplace in a framework, there's reduced confidence in both the framework and the tests. So, at a high level, in this talk, I'm going to be digging into some details about how we made our framework more reliable. There's going to be some architectural insights, like I said, some safety nets that we've set up. And after we've covered the high level overview of that, we're going to be digging into a case study to discuss a real project that we've done, which is to upgrade our framework and our tests to use Webdriverio V5. So to give you a high level overview of our framework, it's based on JavaScript. It uses WebDriverio. It supports test runs in multiple desktop and mobile browsers. It has integration with Sauce Labs, and we have Selenium grids and other infrastructure set up internally. And we have a lot of custom features that we've built for our partners, such as test stability validation, CLI, test selection. And another thing about our framework is that we've tried to build it as an extensible platform. So we have partner teams which have built abstractions on top of our framework, or extensions to the framework itself. So with that in mind, what did we do to improve reliability of our framework? To break it down, we did three main things, right? We wrote modular code, or started writing modular code. We started extensively testing the test framework, and we set up early warning systems or early feedback systems. Modular code and unit tests are actually awesome, and that's a fun fact. So what do I mean by a modular code base? So what we have done is organized our code into bite-sized logic pieces or utilities. And then we have these high-level feature functions which harness these utilities. And while building these utilities and features in place, we have made them testable. So those pieces of code are testable. As an example, you can see here is we have a failed test consolidator service, which is a feature function, which harnesses the utilities in the test consolidator utils. And as you can see, both of these guys are tested. And if you think about it, the test in the test consolidator utils is testing the implementation details, whereas the failed test consolidator tests are actually testing how everything's harnessed together or how everything's fastened together. So what were the benefits that we saw of this organization, to speak? Reduced redundancy. We saw high reuse, so because the implementation details are all encapsulated in utils, these utils can now be shared by multiple features or services. It helped us write backward compatible code. Again, the implementation details are, in the utils and not the harnessing feature functions. So the feature functions, therefore, mostly remain the same, even if the feature or the underlying implementation changes. And these guys were pretty easy to mock as far as mocking goes. And we were able to write atomic unit tests. And another benefit to that is that you could really test the implementation in quite detail. And if you think about it, if a feature is very well tested, that provides a good documentation to your code. What feature, what is acceptable to a particular functionality, what's not acceptable, right? And code speaks more than words, in my opinion. And yeah, definitely therapeutic exercise. Another thing we did is set up some unit test coverage metrics. Although we did initially set it up to see how far we'd go, almost like gamifying the system, how good we'd do. But I think right now I gain a lot of value in understanding which areas need additional testing or attention. And in my experience, I've noticed that code that probably hasn't been tested is not written in a testable fashion or in a modular fashion. So yes, you'd have to refactor that code, therefore needs more attention, right? End-to-end testing. Now, this is a fun thing. So we actually use our test framework to test the test framework. And no, this is not a Christopher Nolan flick. We have a lot of customizations on our framework, a lot of unique things that happen within our frameworks. For example, in this case, we are testing a very straightforward use case of whether a before hook would work, right? So that's what this test is doing. It's just making sure that a before hook can execute without throwing an exception. Although it might seem a little simple, we've had regressions in this area before. So, it a little goes along when it comes to testing. So we have a few hoops that code has to jump through before it can be published and available for tests or test owners to use. We have pre-commit checks. So even before you could commit code in your local branch, we have a few linting prettier checks that run. We have pre-push checks, as in if you wanted to push to a remote branch, unit tests would execute locally. And if you were to create a pull request from your remote branch, we would then kick off a Spinnaker pipeline, which would execute a bunch of unit end-to-end tests and a few other validations, and even generate code metrics, code coverage metrics. And after all this is done, everything's hunky-dory, you've merged your code, you wanted to publish your code, we'd still run a few more validations, such as we'd run a segment of product tests to make sure like the real world tests actually work, so on and so forth. So this gives us enough information going in to make sure that, we are not breaking something, which is at least, super obvious. Now that we've have all that covered, let's dig into the case study. This is a real project that we did to upgrade the framework and the tests to using Webdriverio V5 from using Webdriverio V4. Just some background information. The V4 to V5 change list was not backward compatible. I have a screenshot here. There were way too many signature changes, method changes, scope changes. I think we compiled this list internally. It was more than 100 just method of function name or function related changes. So it was definitely a big breaking change, and we had to be strategic about it, especially because we had thousands of tests on V4 already. And at the same time, we were in the process of onboarding new teams to the framework, and it did not make sense to onboard them with V4. So what we decided was to support both V4 and V5 at the same time. So therefore, the version would be selected at runtime. It's I think one of my colleagues had a good analogy about it. It was like trying to change the wheel while driving, and I've come to agree with that. It was not super ideal, but in a real world, we do have to make adjustments and exceptions to certain scenarios. We did add a lot of unit tests and end-to-end tests, and ran them for both V4 and V5. Although initially it seemed like supporting both V4 and V5 was a huge complexity, it did serve as a boon in disguise. What it did was it gave us the ability to, migrate in a phased manner. So what was the migration strategy that we used? So we decided to support V4 API in V5. So that means we added a temporary abstraction layer with V4 API methods, but behind the scenes, they would actually run the V5 API. With this, we were able to actually run the tests in V5 with close to zero changes to the tests. That is, the test would still have the V4 API, but they would be actually running in V5, and that would be determined at runtime. So while doing this, we made sure that we stuck to the whole modular design, unit tests, end to end, the whole design principles that we adhere to. And once we were able to run these tests in V5, we started testing them extensively just to make sure what else was breaking with this upgrade. And we had the ability to switch back to V4 if we saw any issues, right? Um, and with that power, we were able to migrate the tests, in a phased manner. We were able to create multiple pull requests, do extensive testing. We were in constant communication with the test owners and gradually move all the tests from using V4 API to V5 API. And just a quick fact as to why we chose to not pick an attempt, not pick a more permanent abstraction layer. Our partners wanted transparency. They didn't want middleware between them and WebDriver IO. They wanted to interact with the APIs directly and wanted to manage the abstraction themselves. So that's the reason why we decided to just make this a temporary, thing. So, what were the benefits of this strategy? The transition from the end to end, from the end user point of view, was pretty smooth. Whenever we encountered unexpected issues, we would switch back to V4, and that was pretty easy for us to do. It was a feature flag essentially for us. And we biased towards using smaller commits and lots of them at that. But that made things easier to review and test. I mean, imagine if somebody makes a change to somebody has a PR for a few thousand files, and you were only concerned with 5 files. Like, it wouldn't be an efficient way for you to even begin to review that process, right? So doing this helped our test owners to be more involved with the process, and it was very transparent to them, and we had an open communication channel with them. So overall, I think it was relatively smooth transition given the complexity of the project. So yeah, in summary, I think these strategies and principles definitely work. Um, we were able to maintain this trust and the stability. Tests, early warning systems, the phased migration strategy, they all worked great, in fact. And remember the temporary abstraction layer that we added? And, since we used modular design, cleanup was a breeze. So yeah, that should be it for me.